Okay, so this is a video about 4.1, the greatest common factor. Here we're looking for exactly that. Okay, the greatest, the biggest common factor. So the first thing that we're going to look at is at the top of your sheet here, where we're moving from something that looks like this to this. Or when we have something like this and we're moving back to this. So when we do this to this, we call this expanding. And that's what we've been working on the last few days, is expanding. When we go in the opposite direction, that's called factoring. And that's what we are going to be getting into in the next few sections. Okay? So going from this to that is expanding. Going from this to that is factoring. Now, in example 1 here, it says state the greatest common factor, or GCF, okay? So you need to know that short form, that GCF stands for greatest common factor. And we're going to try and find the greatest common factor between all of these. So with this, we just have numbers, and in this case, we're looking for something that's in common between 2, 4, and 6. So with 2, the only factors we have are 1 and 2. With 4, we have 1, we have 2, and we have 4. With 6, we have 1, 2, 3, and 6. And from there, we ask ourselves, what's in common? Well, they each have a 1 in common. They also have a 2 in common. And we are going to go with the one that is the greatest. So in this case, 2. So the greatest common factor here would be 2. Now if we look at the next one, you've got to think about all the factors. So everything that multiplies to get each one of these values. Okay? Ideally, you know your multiplication tables pretty well, and hopefully you see that 3 can fit into all of these, okay? 3 goes into 30 10 times, 15 5 times, and 27 9 times, right? Because 10 times 3, 5 times 3, and 9 times 3. So they all have 3 in common. Now let's look at the next one, 63, 81, and 18. So here, we're still looking for the greatest common factor, but our numbers are getting pretty big. But what you want to do as a rule of thumb is look at the smallest number, because it has to have the factors of the smallest number. So for 18, we can do 1 and 18, we have 2 and 9, and we have 3 and 6. Those are the only factors that we can possibly work with because of the fact that 18 is our lowest number, and those are the factors associated with 18. So now we're going to look to see what also fits into 63 and 81. So if you didn't know, because 63 and 81 are so big, you can simply just divide it out. So 63 divided by 18, nope, it does not work. It's 3.5. Okay, so 18 doesn't work. What about 9? 63 divided by 9. Oh, I got 7. That works. So let's see if it works for 81. Yep, it works there too. Okay, so in this case, our greatest common factor is going to be 9. We don't need to check any of the other ones because they're all smaller. We're looking for the greatest common factor, which is why I started with the biggest number and worked my way down. So the other ones may be in common, but we always want the greatest common factor, the biggest one. So now let's move on to D here, where we're actually looking at letters, okay, variables. And it's no different, but now you're looking at the degree associated with that variable. So it's always the lowest degree that they are, or the highest degree that they all have in common. So in this case, it's just going to be x, okay? Because this one doesn't have a 2 or a 3, it's just x. Here, we have to look, what does all 3 of these have in common? Well, they all have an a in common. Let's look here. X to the power of 6, x to the power of 10, and x to the power of 8. What do they all have in common? Well, all of them are going to have x to the power of 6 in them, okay? Because this is x to the power of 10. So that's the same, if I say x to the power of 10, that's the same as saying x6 and x4, right? Because we would add those together to give us 10. So there's my x6. Okay, and same thing with x8. X to the power of 8 would be x to the power of 6 times x to the power of 2. Okay, and there's our x6, that is the greatest common factor. Now let's look down here, it gets a lot more complicated, okay? Look at your A's first. What do I have in common with A's? Well, I've got a 2, a 5, and a 4. So I'm going with the lowest one, which is 2. And then for B's, I've got a 3, a 1, and a 4. The lowest there is 1, so just B by itself. Now I'm going to go here. Look at your numbers. What do I have in common between 15, 5, and 10? 5 is in common. Then I'm going to look at the A's. I've got 5, 10, and 15. Well, my lowest one is A5. Over here, you look at the numbers. There is nothing in common with the numbers, okay? 3 is common with 3 and 30, but not 20, okay? So in this case, we don't have anything common between the numbers. Then we look at X. Well, I've got an X here, I have an X here. Oh, no X there. So that's not in common. What about Y? Y there, oh, but not there. No commons. What about Z? There's no Z there, but there and there. So in this case, there is no greatest common factor. There is nothing common between all 3 things. Okay, let's move on. To find the greatest common factor for a given expression, find the factors of the numbers and factor out the common variables with the lowest degree, right? So up here I had 5, 10, and 15, and I'm taking the one with the lowest degree. Okay, let's look at this. Example 2, factor by finding the greatest common factor where possible. So I'm going to look here, 2x and 6. So look at your numbers first. Is there something in common between 2 and 6? Yes, 2. That's going to go on the outside. Everything else is going to go in the brackets. Because I don't have x in common here, I only have it here. So in this case, I don't have x as a greatest common factor. The only thing I have is just the 2. So 2 times 1 is going to give me 2. I'm going to add the x in there because I want the x to show up. So 2 times x is going to give me 2x plus 2 times something is going to give me 6, 3. And you actually don't need to have the 1 there, so it's 2 times x plus 3, right? And if you were to expand that out, you can always check your work because you should always be able to get back to your original answer if you have factored correctly. Look here. Do we have a greater common factor here? No. Okay, so there's nothing else that we can do with this question. What about here? I have a 5 in common between 5 and 10, but m is not in common. So I'm going to put my brackets. 5 times what will multiply to give me 10? I need my m, and 5 times what is going to give me negative 5? Negative 1. Okay, and if I expand that back out, I'm going to get 10m minus 5, so I know I did that correctly. Okay, let's take a look at this one here. What we have in common, we have a 4 in common between the numbers, and we also have an x in common. So how am I now going to have 4x times something to get 8x squared? Well, 4 times 2 will give me 8. X times x gives me x squared. Now, 4 times what is going to give me negative 4? Negative 1. And x, how do I get another x? Well, I don't need to do anything, because I just need to multiply by 1. Okay? So in this case, my greatest common factor was 4x. Now, for the rest of these, I'm going to do them on the side, and I'm going to take a picture of the results and post it. Okay, for you to be able to copy down in your notes. Now, there's a special little rule where we do factor by grouping, and what it allows us to do is if we have the same group, so see here how we have WZ and then we have a WZ, there's a rule that says we can take that WZ and then we're going to take what's not in with the WZ, and that's going to be our other bracket. And it's as simple as that. And that's how we factor it. Because in this case, that's actually the greatest common factor, is W minus Z, because it's common there and it's common there. And we're putting the rest, everything that's left, in the other bracket. Okay? So if we looked at this one, we'd have x minus 3. That's what's in common. And we're taking what's not. So 1 plus y. What's not inside the brackets, what's not in common, and that makes up our other bracket. Okay, same thing here, guys. I will write out the examples more in detail for the rest and post them as a picture. Okay, and then over here, we're factoring by grouping again, but we're not given the first step. So if I look here and I look for the greatest common factor, I can see that I have an m. That's going to leave me with x plus y. And then here, I have an n in common, and that's going to leave me with x plus y. And I have the same thing in each bracket. So that's going to come together. And that's what's outside of my brackets. Okay, so the same thing, I will post the rest of these examples online as well. Please send me your questions and let me know how this video worked out.